Hi, everyone. Thank you for making it to the studio this early in the morning. True dedication to our passion and our craft. My name is Madeline Gannon. I am a designer, a researcher, and a robot whisperer. I head Automaton, a research studio based here in Pittsburgh that is exploring better ways to communicate with machines that make things. And today I really like to share with you how we're exploring the future of automation. Computational design really began in large part out of tools for computer-aided design and computer-aided manufacturing. And automation in particular has a really interesting relationship with Pittsburgh. And there's many benefits that it brings, from making things faster, cheaper, more reliable, with more efficiency, and making commodities more affordable to wider swatches of the population. But despite these many benefits, automation comes at a human cost. And as these machines get more intelligent and more autonomous, the balance of power between humans and machines is beginning to shift in the machine's favor. Besides that, though, these machines have superpowers. They have superhuman speed, superhuman endurance, superhuman strength and reliability and precision. And it's just unfortunate that they've kind of been trapped inside factories and used in a very narrow way. So the work that I do looks at ways to reappropriate these automation machines to enhance, augment, and expand human capabilities, not replace them. That's the future that I work to create. I'm really passionate about inventing better ways to communicate with machines that can make things. For a long time, industrial robots have been the culprit of automation and replacing human labor. Basically, all the easy tasks to automate have been automated. Now what we're working on is using these tools to enhance or augment human labor. And that to me is very exciting. Industrial robots are really fantastic CNC machines. You put a different tool at the end of the arm, and all of a sudden they can do a whole different thing. So in the morning you can be doing spot welding, in the evening you can be doing painting. It's just highly adaptable. Another thing that I'm really working towards is finding ways to bring these machines out of factories and into live environments. So onto construction sites or onto film sets. There's chance for unpredictable objects like people to be moving into the environment. That's one of the reasons why I wanted to build the system, to give this robot eyes so that it could actually see me and we can safely collaborate in a shared space. If I'm wearing or if I'm holding these motion capture markers, it knows where I am in space, it knows how I'm moving in space. Now all of a sudden we can give the machine a nuanced understanding of our intention in that space. You can get someone who's never... So a central theme in how I explore the future of automation is human-centered design. When we interact with technology, in many ways, we're usually interacting with it as a black box. The burden is placed on us to understand what's going inside, and we have to adapt our way of thinking to how this machine, this computer interface, or this tool is operating and thinking about the world. Human-centered design tries to invert this relationship and find a way to create a shared understanding between people, machines, and places. And in many ways, this was the root motivation behind some of our earliest computer-aided design and computer-aided manufacturing tools. And this agenda is still latent in what these original authors created. So although today these things are quite standard and not very open to outside sensory input, at the very beginning, the authors wrote about these things as finding ways to join man and machine in intimate cooperative complexes, or for man and a computer to converse rapidly through the medium of drawings. This is kind of a radical idea that kind of fell off the map after the 60s.
in many ways, we're still using these machines in the exact same way when they were built almost half a century ago. So at the same time, in the early and late 60s, there's another group of folks who are doing really interesting things with technology. This is from the landmark exhibition, Cybernetic Serendipity, which really brought together the first generation of artist engineers exploring new ways for humanity to be augmented by technology. And there is a lot of brilliance and ingenuity in this show, but the one person who I am endlessly inspired by and in constant admiration of is Edward Ignatowicz, a pioneering roboticist and artist in his own right. He developed these magnificent actuation and sensing systems that breathed life into these mechanical creatures. So this is one of my favorite. This is sound-activated mobile. And this is Sensor, a much larger scale, but they use the same basic technology. They use hydraulics for actuation, so it's pumping oil to make this thing have some kinematic movement, and sound sensing to sort of sniff out whomever is closest by. Really, really simple system, and yet incredibly well designed to make these things into creatures. And he really begins to illustrate an alternative vision for these machines as creatures and not things. I see myself and my work sort of chasing this same trajectory, kind of picking up the pieces where he left off and trying to begin to see how the technology today can continue that conversation and that exploration. But I didn't start exploring this with giant autonomous robots. I instead started exploring how we can design with intelligent autonomous virtual creatures, like these squids here. So as this audience is kind of well attuned to, for anyone learning 3D modeling, you can know how difficult it can be. Geometry as an abstraction can only do so much. It's fairly static, and you have to do a lot of mental gymnastics to get your abstract idea into a static form of geometry. What I tried to do is figure out a way that we can reach into the digital world and create something with this virtual creature that neither I or it could create without one another, finding a way to sort of stretch the boundaries of our imagination. So the key insight here was finding out a way to not only embed some independent autonomous behaviors into this squid to navigate and interact with my hand, but to actually embed the knowledge of an experienced fabricator into the anatomy of this virtual squid. So this thing is built out of a system of springs that inflate and preserve a lot of the properties for 3D printing that many people have to learn through trial and error and many failed prints to do. So for here, no matter how you manipulate this thing, it can always be ready to print and go. And the magic that happens here is that, you know, this virtual geometry that exists in our computer transforms into this in physical matter. So Reverb is a ready-to-print, ready-to-wear design tool for draping intricate designs around a 3D scan of your own body. So here you see the hand draping the squids across your body. Because the properties of 3D printing are baked into the actual anatomy of this creature, you can always print it no matter what. And because it's designed around a scan of your body, it's also ready to wear. You know it's going to fit. So with this human-centered interaction with the fabrication technology, we can get strangely anatomical artifacts that also push the tolerances of fabrication process and create exquisite forms that can conform and deviate from the body. So just a few seconds, you can get these intricate designs that balance on the shoulders or just barely rest on the nape of your neck because the intelligence of the designer and a fabrication machine are directly embedded into the underlying structure, the underlying logic that these artifacts are generated from. And this was a really satisfying process for me, the ability to interact with this creature and create something and sketch with it around my own body. But what I wanted to do is find a way to bring that intelligent animate geometry out of the computer and into the real world to engage directly with me. And if we're going to design things for the body, why not just design them on the body? So Tactum is a gestural interface that detects your skin-based interactions to let you 3D model directly on your body. So again, it's taking this intelligent animate geometry and it's attaching it to a physical environment that you can interact with. And the same principles from the previous project hold true. You always get something that's ready to print and you always get something that's ready to wear. So here's a little look under the hood for how we're doing the body tracking and hand segmentation. So here we see skeletal tracking on the arm. From that, we can segment the forearm and generate interactive, intelligent, fabrication-aware technology. And then by tracking the other hand and looking at its proximity to the skin, and by looking at a very, very thin sliver above your arm, you can actually detect a wide range of interactions using just one sensor. So this is an array of 8 interactions from touch, poke, and grab to your other hand also can begin to manipulate the form that all go to a CAD backend to let you have this sort of fluid, intuitive interaction to make this 3D thing on your body. So Reverb gave me intelligent, autonomous geometry, and Tactum brought that geometry out of the computer and into the world to see and respond to my body. So the next way for thinking for me was, why can't I feed this intelligent contextual geometry that I was already setting to a 3D printer, a 3-axis robot, to a big robotic arm, a 6-axis robot? And it turns out that there are fairly good reasons that these are very dangerous machines, and when you look through the user's manual, you are just bombarded with visions of your impending doom. And in industry, this holds true as well. Like when you go into a factory floor, when you go into places where there are industrial robots around, there is strict separation between humans and robots. They are made of hardened steel, we are made of soft, squishy flesh, and those things really shouldn't come into contact with each other. But part of coming into robotics from an outside discipline is that you often don't know the things that you don't know you weren't supposed to do. So one of my first projects actually working with industrial robots was making a massage bot. So this is like when you're super frustrated programming your industrial robot because it never really listens, you just run this program and it leans into you and you get a little back massage, and it's an intelligent back-centric interface. But I've done a lot of work with robots, trying to make them easier to use with open source hardware projects. developing open source software, to help other people do creative things with robotic arms. And I'm quite interested in trying to illustrate any alternative relationships that we could have with these machines that really fit outside of the spec for traditional automation. And last November, I was fortunate enough to have the opportunity to take these ideas out of my research studio and into the wild at the Design Museum in London. I was invited to contribute an immersive installation to Fear and Love, and they asked me to sort of tackle the topic of automation. What's our fear and love of automation? What are the complexities that this brings to us in modern life, and how can we begin to grapple with it and work our way through this messy topic? So with my orange robot Abba here, working with her so much, I had, we built this bond together. It was like this little puppy following me around. And I wanted to share this experience with a range of museum goers that perhaps have never seen this machine before, have never come face to face with this piece of infrastructure that makes a lot of the things that they ride in and work in and live in. So I was inspired a lot by Victorian zoos, where you would have these feats of daring between trainers and giant beasts, or just having exotic animals brought into unfamiliar places. So I decided to bring this giant industrial robot to live in the Design Museum for 6 months and to provide a point of first contact between visitors and our companion species here. And in bringing this machine into a public setting and engaging with people who have never seen this very alien machine, the only thing that we could really do is work on a body language. The interaction design here is really where the artistry is. We wrote a lot of software for it, but the thing on display is really the intangible interaction design. So this is actually how Mimus sees you. She has sensors embedded around the perimeter of her enclosure that tracks everyone at the same time. And so here we are, we have a lot of people engaged. She sees not you personally, but she sees how tall you are, how long you've been there, how close you are, how active you are. And from all of these variables, it goes into a ranking system for her to find the most interesting person. Yeah. So just like when you go to the tigers at the zoo and you're tapping on the glass, you really want them to pay attention to you. Sometimes you're just not that interesting, and we want to recreate that experience with Mimus. So when the sensors are hooked up and calibrated in a space, Mimus doesn't actually look through her face. She sees everyone simultaneously. And this is installing at the Design Museum, and the ceiling installers are having a bit of fun with her. And then the final installation where she's brought to life inside the Design Museum. And there's a really restricted material palette that we have working with here, right? We have, again, everything is driven by really simple geometry, telling her to go to a point in space with a simple orientation. But we have a couple other ingredients to sort of breathe life into this machine. Let's see there. One of it is the sound of her motors. So I worked a lot at beginning to find motor movements that not only held a posture, but built a little bit of a language for her to call and reach out to people. She's a little bit obnoxious sometimes, If you don't keep her attention, she gets bored and she finds someone else. And I was really surprised at the range of empathic responses that people would project onto this machine, from friendly curiosity to flirtatious teasing. And then also finding it very creepy and distrustful. Like, here you have this giant machine, this lump of metal and motors, and yet I'm somehow think it's adorable. Like, that is very manipulative. And that these are all conversations that I'm excited to have with a range of people who, aren't in a tech company and aren't in a research lab, that are just out in the wild going to a museum. So for this non-humanoid machine to see and respond to your movements in such an animal-like way, it's really difficult to not project our own emotions onto this animate vessel and to start seeing it as a living, breathing creature instead of a thing. And what's so amazing about these machines is that they're just controlled with geometry. They're just controlled with the same tools and the same things that we've been using for the last 50 years. But if we can inject a little bit of intelligence and a little bit of strategic design, we can transform and appropriate them in ways that go beyond their intended use.